Okay, this problem says a particle moves around the curve and the equation of curve is given by this equation, r is equals to 1 plus cos phi with a constant angular velocity omega. So this says this moves with constant angular velocity omega. So this is d theta as d theta over dt is given to you. Now the next part, find the radial and transverse component of velocity and acceleration at any time t. So we have to find the radial component of velocity and tangential component of velocity and radial component of acceleration and tangential component of acceleration as a function of time t. So this is my task. Now this is quite easy. So to find velocity, so let me write r is equals to, I think all of you are able to see, a 1 plus cos phi. So this is my radius vector. At any point of time, radius vector is given by 1 plus cos phi, a into 1 plus cos phi. So if you remember, in the class we have already derived, so radial component of velocity is given by r dot. Are you getting? And tangential component of velocity is given by r theta dot. So you see your copy. So this is given by r theta dot. That is, the radial component is dr by dt, and this is r d theta by dt. Are you getting or not? Now this is for velocity. We have also derived in the class radial component of acceleration is given by r double dot minus r theta dot whole square. So this is the radial component of acceleration. Tangential component of acceleration is given by r double theta double dot plus 2r dot theta dot. So this we have derived in the class. So radial and tangential component. So this diagram is for velocity and this diagram for acceleration. So now let us find velocity, radial component of velocity, that is Vr. This is simply r dot, and r dot is nothing but if I differentiate this. So differentiation of this is a and differentiation of 1 is 0, and cos theta is minus sin theta, and theta is d theta by dt, but d theta by dt is omega. So let me write omega. So this is the radial component of velocity. This is minus a omega sin theta. Now let us find transverse component of velocity. So this is nothing but r theta dot. So you have r theta dot, and r is given by a into 1 plus cos theta. Are you getting? And I have to multiply theta dot. Theta dot is nothing but omega. So this is a omega. So I can write tangential component of velocity omega 1 plus cos theta. Now let us go for acceleration. So radial component of acceleration is given by, so radial component of acceleration is given by r double dot minus r theta dot square minus r theta dot square. So let us find r double dot. So we have already find r dot. So this is r dot. Are you getting? If I want to find r double dot, so simply I have to differentiate this. So minus a, and differentiation of sin theta is cos theta, and d theta by dt, that is omega into omega square. I don't have to differentiate omega because omega is constant, that is given in the problem. So this omega I don't have to consider again because this omega is constant. So this is, now we will have next term, that is minus r. R is given by a into 1 plus cos theta into theta dot square. Theta dot is omega, so this is omega square. So if I take a omega square minus a omega square common, so I will have here cos theta, and here I will have 1 plus cos theta. So you see I am getting radial component of acceleration is minus a omega square 1 plus 2 cos theta. Now let us say tangential component of acceleration, and this is given by, we have already derived, r theta double dot plus 2r dot theta dot. Now you see theta double dot will be 0 because theta dot is omega, and if I differentiate omega again it will be 0 because omega is basically constant. So that's why d omega by dt will be 0. So this term will go. Now let us consider this term 2 r dot we have already derived. So you see here r dot, that is minus a omega sine theta. So I can write minus a omega sine theta, and theta dot is nothing but omega, that is d theta by dt. So this will be simply minus 2a omega square sine theta. You are getting? So this is the tangential component of acceleration. So if you want to find total acceleration vector, that case you have to apply ar square plus at square root over. If you want to find total velocity vector, you have to apply vr square plus bt square in the root. If you want to find, if you are interested in angle between radial and tangential component, in that case you have to take tan theta. So if somebody asks what is the angle, so you can always multiply, you can always divide. So this is a one vector. So let us say this side you have velocity tangential, this side you have velocity radial. If you want to interested in angle, in that case you can have, this is the resultant vector. So resultant velocity makes an angle theta with the radial direction. In that case you can derive tan theta will be nothing but this by this, that is Vt by Vr. Are you getting or not? So theta is the angle that makes the resultant velocity vector with the radial direction. Are you getting? Similarly you can find for the acceleration also, that in that case you will have radial component of acceleration and tangential component of acceleration. If acceleration vector makes an angle alpha with the radial direction, in that case tan alpha will be given as, so I can say tan alpha will be given as this angle, that is the tangential component by radial component. So at by ar. Are you getting? I think all of you are getting this one. So this is pretty easy problem we have here. So some of you have missed to copy. So let us copy fast and then we'll discuss the next problem. Easy problem. Only thing is you have to remember the radial component of acceleration is given by r double dot r theta dot square. Tangential component is given by this expression. If theta dot is constant, r theta double dot becomes 0. So correspondingly you can write the term. So it is better to remember the radial and tangential component of acceleration. At least you also remember radial and tangential component of velocity. If you are not able to remember, then please derive this accelerations in your question itself. We'll discuss the next problem.